Hey everyone, this video is going to go through the FRQ from 2016. This is number 5. And for our purposes, you only needed to do part A here because this is the only part that would be covered by this year's exam. So what we have here is a funnel of height 10 inches. We have circular cross sections and they're giving us a formula. So for at height H, the radius of the funnel at a particular height is given by this function here. And then they're telling us the units of R and H are inches. So this funnel contains liquid that's draining from the bottom. At the instant when the height of the liquid is H equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. So at this instant, what is the rate of change of the height of the liquid with respect to time? So when we see this, the rate of change of the height of the liquid with respect to time, that should clue us in right away that this is a related rates problem. So let's see, I'm asked to compare the rate of change of the height of the liquid with respect to time. So we have a formula here that relates the radius to the height. So I'm going to go ahead and copy that down. We've got R equals 1/20th times the quantity 3 plus h squared. And so in a related rates problem, I know I have to take the derivative with respect to time. And that's going to involve implicit differentiation. So on the left-hand side, we just have the derivative of r. I know that derivative is 1, but then I have to do dr dt because this is respect to time. So I get dr dt on the left. On the right side here, I have a constant times a function. I know the derivative then is going to be the constant times the derivative of that function. So I have 1/20th. Now, the derivative of 3 is just going to be 0. The derivative of h squared is 2h. And then I have to multiply by dh dt. So now if I simplify that, I get, let's see, 2 over 20 is going to give me 1/10. So I have h over 10 times dh dt. And that's equal to dr dt. So now there's a couple quantities that I have to figure out to be able to solve this problem. So it looks like I've got an h here. I've got my dh dt, and then I've got dr dt. Well, they're asking us about, the question asked for the rate of change of the height with respect to time. So that's my unknown. I can leave that as a question mark. For h, it says we're solving this problem at the the instant when the height of the liquid is h equals 3. So that's what we're going to plug in for our h. And then they're telling us the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. Now, this word decreasing is really important. That tells us that our dr dt is negative 1/5. So now this is good. We only have one unknown, so we can plug in what we do know and solve for our unknown. So I'm going to have negative 1/5 equals 3 over 10 times dh dt. So to solve for that, I can just multiply by the reciprocal on both sides. So then over here, let's see, we get negative 2/3. Here, the 3/10 and the 10/3 cancel, so I get dh dt. So now I want to make sure I include my units. So dh dt is negative 2/3. And then let's see, our height and radius were measured in inches. So that tells me it's negative 2/3 inches per, and my time is measured in seconds. And that would be our answer there. As far as scoring here for this year's exam, they gave 2 points here, or excuse me, not there. Let me undo that. It was 2 points here for the derivative. So they were checking, did you remember this implicit piece here? So 2 points for that, and then 1 point for the answer with units. And again, that was the only piece we had to do there. So you're done.